Me too.
What's that?
It seemed like you guys had questions.
Yes. Number
Yes.
49. I can't remember how to put like the equations together.
Oh. Look at chapter 1. So 49 in the review. Here we go. What about Wilt Chamberlain? Yeah. Okay. Yeah, Wilt Chamberlain is 100 points. Oh, okay. Okay, so there's got this problem, right? 49, the Wilt Chamberlain problem. He scored 100 points. Okay, so that's one piece of information they tell me is he scored 100 points. Right, and in fact, if you read through this whole question, how many things are there that I don't know? 2 things.
Yes.
So how many pieces of information do they need to give me? 2. I like it. So if I said I'm twice as old as you, is that enough information to figure out our ages? No. I got to have one more piece of information to kind of work together to figure out our ages, right? What else did they tell me? He took only 2-point shots and 1-point foul shots. Made a total of 64 shots. So both of these have to translate into equations. And then you're free to do elimination, substitution. Do those words sound familiar? You could even do it graphically if you're feeling insane, right? Some of you guys are like, I didn't feel insane before this class started. So what are the 2 things I don't know? What are they?
How many 2-point shots and how many 1-point shots?
So the names of the things that are not known. So one thing about word problems is you do not have to immediately be able to set up an equation. That is insane. So if you feel like you're supposed to read through and just set up an equation, you are putting way too big of it. You're setting the freaking bar like 20 feet high. You ain't got to do that shit. You read through it and your first concern is English. You don't care about the math at all. You say, what are the players in this problem? If it's a triangle, maybe it's 3 angles. The small angle, the middle angle, and the large angle. Whatever words they use in the problem, you write those English names down. Then I'm going to translate it into math. This is a translation problem. Math is a foreign language. So I've got to translate. So what are they? So again, I'm sorry. It was 1-point shots, right? Foul shots. And 2-point shots. Now you give those. Now I've got the English ideas down. This is all in English here, right? I don't really know any other languages too well. Now you got to start giving them math names. So what are you going to call these 2? You can call them X and Y. You can call them A and B. Me, I would call them maybe. This is kind of sick. Well, F. I wouldn't use T necessarily because my T is. Maybe I'll use a capital T. There you go. F and T. It's totally up to you. The X and Y is relatively arbitrary. X has got a very interesting history as to why we use it. But it could have very easily been something else. To be honest, it doesn't matter. It could be a happy face in a box. You just need 2 symbols that represent the shit you don't know instead of empty spaces, right? Can I now rewrite this idea mathematically? In fact, what are these? I'm missing one little thing here. And this is almost something I don't need, but just to make sure you got number of for each one, right? Okay. How do I rewrite? Well, let's do the second one first. The second one's easy. The total one's always easiest. How do I rewrite the second thing in mathish? He took a total of 64 shots, and he only took foul shots in 2-pointers. So what must be true about these 2? They have to add to be 64. That's it. It's not that big of a step from English to math in this case. All right, so this one goes F plus T is 64. That's my second piece of information translated. Number of shots plus number of shots equals total number of shots. Right. Basketball, not bar.
Well, I got that, but then
Now the first one,
Yeah, that's what, yeah.
you ready?
Yeah.
How many 2-point shots did he take, T? Every single 2-point shot he took, how many points did he make for it? 2.
Yeah.
So how many total points did he make from the 2-point shots? 2T. If he took 5 2-point shots, how many points did he make?
5.
If he took 5 2-point shots, how many points did he make? Twice 5.
Yeah.
Well, how many 2-point shots did he take? T.
2.
So how many points did he make from just 2-point shots? 2T.
Oh.
Plus, how many points did he make from the foul shots?
1.
1. So it's just 1 F. So you just put an F. 2 points for every 2-pointer. 1 point for every foul shot. And that's supposed to equal?
64.
No.
100.
Points plus points equals points. You got to be careful. And that's a really quick check you can make. Whatever each thing represents, it better be the same throughout. You can't have points plus points equals shots. That doesn't make any sense. Dogs plus dogs equals cats. No, that doesn't. What? I don't want to come to your house. I'm not sure what's going on. All right, let me stop here. This is the hard step. The rest of it should be easy. The hard step is making the equation from what they told me, right? We all know this. Yes. And why is it hard? Because it's frickin' translation. Anybody ever take a foreign language? Yes. What's the hardest thing to do is freaking put sentences together that actually make sense grammatically and all that kind of stuff, and remembering all the words. Holy shit, that's hard. Okay, now can somebody, now the rest should be easy. What method does somebody want to use? You can use elimination or substitution. Do we all remember how those two work? Maybe we'll do this one both ways. That might be a good idea. Let's do substitution first. So the idea with substitution, I always think of substitution as being very subversive. Yes?
You can get F by itself.
Good, I love it. You solve one piece of information for a letter, and then you plug it into the other one. So like, I always think about invasion of the body snatchers, replacing it with something. So either one, really. Which equation do you want to solve for a letter? Doesn't really matter. 1. So what letter should I solve for in 1? F, because otherwise I'd have to divide and get fractions, and if I don't have to, I'm not going to. Do you think I'm pretty good with math? You'd hope so. You're up there, man. You could have just somebody came in. You're like, nobody's here, I'm going to take over. I'm pretty good at math, but if I don't have to deal with fractions, I'm not going to. Can I? Of course I can. Shit. But if I don't have to, I'm not going to. So I'm going to solve for F, so I don't have to divide and make fractions. So of course to solve for F, how do I solve this for F? No, I'm not solving for an intercept. I'm just solving for F. Get F by itself. Subtract 2t, right? I know sometimes it's like you're not sure what the hell I want from you, but that's it. Just solve for F. So what is F? 100 minus 2t. So crazy-ass math people would say, I know what F is. It's 100 minus 2t. And you'd be like, you don't know shit. But I do. This is good information. It's 100 minus 2t. Anywhere I see F related to this problem, I can replace it with 100 minus 2t, because that's what the hell F is. So how do I rewrite number 2?
100 minus 2.
Yeah, 100 minus 2t.
Plus t.
Yeah, there. Plus t plus 64. Can you solve that equation? Yes. What was wrong with these two equations to begin with? They both have too many frickin' unknown things. So I use one piece of information in the other piece of information. That's substitution. Yes? Oh, good? All right. So like, for example, somebody's dead. Right? And I'm trying to investigate what I'm like, all right, where were you? And you're like, I was with Frankie. All right, Frankie could have been there with you, helping you kill this guy. Right? I don't know. And then, Frankie was at his mom's house, and they got an alibi. Oh, good. So those two pieces of information, I put it together, and I just figured out it doesn't seem to be you. Did you guess? That's how I use two things together. So here I get, 100 minus t. Can somebody just look at this and see? What do you subtract from 100 and get 64? 36. So t is 36. Now, of course, you could subtract 100, get negative 36, divide by negative 1. But sometimes you just step back and go, let me just think about this for a second. So that means what? what does that mean physically? It means Wilt Chamberlain took 36 two-point shots. And I still have to know how many foul shots he took, right? Well, F plus T is 64. So now that I know one piece of information, I can plug it in to get the other one. And either one, it doesn't matter. They both have to work. That's the whole idea. If I graph these two lines, it would be a little weird because it'd be a t-axis and an f-axis, but get over it. The answer would be where they meet. So it doesn't matter which line you pick, it's always going to come back to the same point. So if I put 36 into here, what do I get for a t? What do I get when I solve for f? 28. If I put it in here, twice 36 plus f equals 100. I get 72 plus f equals 100. I get f equals 28. Doesn't matter which one you pick because they both have to agree because they're both supposed to be true at the same time. So then the free throws was 28 free throws. 36 two-pointers. 28 free throws. Or they call it foul shots, whatever. Let's start with F, so both words. If you don't know basketball, I'm sorry. Some of you guys might not know basketball too. So you can put foul shots, whatever. Is that cool? Is that all right? I mean, that's how almost every word problem works. Your very first concern, I don't care about 5 less than twice. I don't care about any of that shit. I just care about, is it Bob and Frank and how much money they made? I put Bob and Frank salary or whatever. And then I give them math names, and then together they made 20. Oh, now I can make an equation out of it. And if it's a triangle, you draw a triangle and you label it to help yourself kind of give yourself a visual anchor, right? Okay. I know word problems are so hated because they're hard, but they're the most important thing in freaking math. Yes?
24.
Is that cool? Is that? I was real quick. I was going to do this the other way. So this is done, but if I used elimination instead, anybody remember how elimination works? Let me write this in the same order.
Kind of ranges where.
See, right now, if I add those equations together, does anything cancel?
Yes. No.
No. So never add them if nothing cancels, because it's like, why did you do that? You made another equation that's got too much shit I don't know. I'm trying to get rid of something. So, yeah, if I took the second one and multiplied it by -1, I'll get negative t minus f. Are you guys with me? So then if I add these two, I get t, the f's go away, 36. Okay. And then I plug it back in and get what f is. It's going to.
X minus 1.
Oh, I multiply by -1. This is one place where I use x for multiplication. Is I'm telling myself what the hell I just did. I took the second equation and I multiplied it by -1.
How do you know to multiply by negative?
Why did I do that? Because now if I add these together, the f's go away.
Okay.
Real quick, why the hell am I allowed to add two equations together? Let me cross this out because we made a better one. If I add -64 to this side, am I not supposed to do the same thing to the other side? So some of you guys, I'm sure in the back of your brain, you're like, whatever, man, just change what math is day to day. That's what no, it can never frickin' change. We know this is true. If I add -64 to this side, I better add -64 to this side. And you can say, you didn't do that, Jeff. Well, yes, I did, because what is -64? Is this. So if I add this here and this here, I did the same thing to both sides. That's why you're allowed to add two equations directly. All right, it's my hopeful Tai Chi. Oh. Huh?
You can do it.
Oh, big cool snake. Oh. Is that cool? I mean, of course, you would plug it back in, get the same F we got earlier. It's the same answer. Math doesn't care how you solve it. At least at this level. You get fuzzy math, he's a little freaky. Yes?
Okay, so say the second the second example was different. So would you still do the exact same thing? Like, for example, like 2t plus 100, like at the top one, like at the 1 for the second. Yeah. So, yep, one like on the right side. Yeah, there we go. So you did that, and then you did the 2, and then you just switched it when you went to the third part, right? So you put like negative t. And
Yeah,
negative
2t minus t is t.
Right.
Yeah, and then f minus f is 0.
Okay.
And then 100 minus 64, so that's equal 36, yeah.
Sort of. Okay. Yeah. So you just switched
Straight
it.
up, added like
Okay.
terms, so on both sides, straight up. Completely legal, because you are doing the same thing to both sides. Yeah. Maybe. Does this sound familiar? You guys remember doing this a little bit?
Are we gonna do doing matrices?
Yes, eventually. Not today or tomorrow. We will be doing matrices. Has nothing to do with, there is no spoon. The matrix. No. All right. Anything else from? Yes.
24.
Oh yeah. Okay. So this might be good. Well, we're gonna focus on factoring later. As soon as I'm done with this, we're gonna focus on factoring out a couple things to give you guys. One of them is gonna focus on the idea of this one. And actually, to be honest, let me show you something about 24 specifically. It's got a really nice thing about it. Everybody got what they want from this here? More than you wanted? Okay. Is my phone still going? All right, good. Sometimes it takes a break right at the beginning. All right, now this one specifically has something interesting because this is not always true, but if I saw something like this, do you know something interesting about the number 16 and the number 25? They're both perfect squares, right? So maybe this thing factors like 4x to make that, 5 to make that, plus, because they're all freaking plus. Maybe. So let me try it and then check it. How do I check to make sure? Well, I already made that happen. I just have to check this. Sure enough, 20x plus 20x. Yeah. So you don't have to do 16 times. You saw 16 times 25, you're like, shit. Right? I don't blame you if you did this problem, you're like, shit. But if that's a perfect square and that's a perfect square, check this. Is that always going to work? No. If that wasn't true, if that wasn't 40, then you'd have to do 16 times 25 and do it that way. But first, just rule out that the easy way doesn't work. Right? We're like weird equation doctors. I'm going to rule out some shit before I do the hard shit. All right. Is that all right for that one? We'll get deeper into some more factoring stuff after this. Anything else from that review section? Yes.
15.
Ooh, yeah. All right. Oh, boy. Oh, this is all right. I need to remember to bring this. All right. We're going to do this two ways. Have any of you guys ever heard of synthetic division? Some of you guys are like, stop. All right. I've heard of synthetic oil. Is this something to do with that? No. I'm going to do this the long division way first. And in order to do that, so this is number 15. And it says basically this. Where'd it go? Plus 2x cubed. 6x squared. Me and 3 just don't get one. 3. It's 2x plus 18 divided by x plus 3. Yeah, okay. Now you could write that as, let me rewrite this without writing everything over again. Is that cool? Now that doesn't necessarily make it look any better. You've got to stop yourself from canceling x's or something. No, you can't do that shit. You got to divide by x plus 3. Is there an x anywhere? No. The top has all this, and the bottom has x plus 3. There's no x anywhere. So let's first remember how long division works, because maybe it's been many years since you had to do long division. You're like, I have this thing called a calculator. Can it do this? No. How does long division work? Let me see, what's a good one to do? Oh, yeah. Let's do this. I like that. All right, help me out. What's the first step in this long division problem? No, stop. Put your calculator away.
Try to see if 14 can go into like 5, but if it can't, you go over and
Yeah.
you take it as a chunk. 14, how does 14 go into 57?
Yes.
And then you kind of guesstimate.
Sure?
14 times.
Yeah, 14 times 4. And like if you did 1 into 5, you get 5. That's like a good place to kind of start. 5 times 14 is too much, so then you say 4. Right? So sometimes you can ignore the second guy to start with. 4 times 14 is 6. Now look what I just did, real quick. Let me overanalyze what we just did. What I wrote up here, I multiplied it by all this. Weird way to say it, but too bad. And then I put the answer there, and then what did I do? I changed this guy's sign, right?
Yep.
Made it negative. Changed the sign. And then I added these two. And then, of course, brought this guy down. What do I do here?
Zero.
Doesn't go in it at all, and then you can bring the 9 down. All right, then you keep going, okay. Right, and basically everything we just did, you repeat until you got nothing left to look at. Right? Okay. Do the same exact thing here. Believe it or not. Let me do one more quick couple. Let me make a little bit better example here. That shows what I really want you guys to see. So if I had something like this, what would you put here and why to start with? 3. Why? Because 2 goes into 6 3 times. So 3 is a good place to start. You guys with me? Do you see how I kind of ignored what that number was to start with? Okay, I really want this to make sense why we do the same thing here. It's exactly what we do here. Everything we do here, we do here. Everything. Just looks different. All right, here we go. So why did I just do this? I did 2 into 6, I put 3, and then I multiply it by 21, right? I don't always ignore the 1. I've got to bring it into account at some point. So what do I do here? X times what is x to the 4th?
X to the third.
Let me put this in different color. Right? You guys see that? 2 times what is 6? 3. So I start with 3, and then I do 3 times 2 and 1, and I get that, and I keep going. Right? X times what is x to the 4th? X cubed. What's the next step? I get,
3x.
sure, but first I get,
X, 4. 3x.
then I change the signs. Those cancel, and if they don't, you did something wrong. 2x cubed minus 3x cubed is,
Negative 1x.
I like it. And then I, sure, and then I
Bring down the 6x.
bring down the 6x squared. And then you repeat, right? Lather, rinse, repeat. X times what is negative x cubed?
X squared. Wait, negative x squared.
Does everybody see what I just did, right? Same thing I just did there. X times what is this? X times what is this? Keep doing the same thing over and over until you go a little crazy. So then, now I take this and multiply. Negative x squared times x is of course this, because that's why the hell I put that there. That's why if that doesn't cancel, eventually you've made a mistake. Negative x squared times 3 is negative 3x squared, and then I change the sign. Oh, you guys love this. Is this difficult? No. Is this something you do all the time? No. Is it long?
Yes.
That's the primary reason you guys are like, I don't blame you. Synthetic division, simplified. You notice how much extra shit I'm writing here that I shouldn't really need to? These are always going to cancel. Why do I have to keep writing this stupid thing? It's always going to cancel, right? Do I even care about the x cubes and the x squared? No, I really just care about the numbers. Yes?
Would it be minus the x squared?
It was.
Oh.
And then we changed the signs, just like we do in any long division, right? Is that cool? Because again, over here was 4 times 14 was 56, but do I add 57 and 56? No, I change this guy's sign, and then I add. I know you guys are like, I subtracted, John. Well, it's the same thing. Subtracting is the same thing as changing the sign and adding. So here I get
9x².
and bring down the 2x.
9x.
And then x times what is 9x squared? 9x. Multiply 9x through. 9x times 3 is 27x. And then I change the signs. Negative 25x. And I bring down the 18. Oh, make it be done. You can sense that in your hand. And then x times what is negative 25x? Negative 25. Multiply it, negative 25x. Negative 25 times 3. 3/4 is 75 cents. Change the signs. 18 plus 75 is 93. Don't put big R 93. That doesn't make any damn sense.
No.
Big R is way gone. What would you do?
You put 93 over x.
Plus 93 over x plus 3. Same thing we do in long division of normal numbers. Of course it works the same way, because what are x's? Numbers. I don't know them, so they're going to be harder, but the processes don't give a shit. How do I divide any numbers? Like this. What is x's? Numbers. How do I divide them? Same damn way. Maybe. All right, now let's look at the improved way to do this. Because there's a lot of writing up here I didn't really need to do. Why was there a 9 here? Because there's a 9 here. Where'd that 9 come from? 6 and 3. Do I care about the x squares? No, as long as everything's in the right order, I don't care about the squares and the cubes. I really just care about the coefficients. So this is really related to matrices. Don't worry if you don't know anything about matrices. They both do the same thing. They say, if everything's in the good order and I'm not missing anybody, here's what I can do. Now watch this. One stupid step I had to do every time was change the sign every damn time, and if you forget to do that, the whole thing goes to shit. Are you with me? So what we do then is every x thing I'm going to forget about, which means I'm going to have that. But what I do then, instead of just putting a 3, I change its sign to begin with. So then I don't have to change the sign ever. It's just done at the beginning. Right? If I change this guy's sign, I would never have to change the signs down here. So this is called synthetic division. I do have a handout about this. I have to bring it tomorrow.
Will we do this later in the class?
Oh, hell yeah. Yeah. Anybody taking pre-calc after this? Pre-calculus? Oh, yeah. This will be a very good friend of yours. Synthetic division is a way to factor things I couldn't factor otherwise. Right? If this thing would have had a remainder 0, that means that this could factor as this times this. Can I factor this? Do you guys know how to factor this? The top thing? No. That's the correct answer is no, you do not. So synthetic division is a way to factor things I can't factor otherwise. All right, so here's synthetic. I don't really watch hockey, but I like to call it the penalty box. So in the penalty box, I put the opposite of this number. What am I dividing by? X plus 3. We're going to ignore all the x shit, because that's the stuff I shouldn't have to write over and over and over. By the way, synthetic division only works if you're dividing by 1x plus something. This has got to be a 1 right there. It's kind of built on that. You could do it if it wasn't, but you have to kind of do some weird little finagling around with that. So here I'm going to put -3, the opposite of this. Why do I do that? So I don't have to change the sign. Okay. I like it. Then is everything in order? Am I missing anybody? Everything's in order. I'm not missing anybody. So I'm just going to put the coefficients. I don't care about the x shit now because it's all in order. So what I'm going to put 1, 2, 6, 2, 18. Shoop. Already it's looking better, hopefully. Of course, you're all like, well, I'll tell you once I see where the hell this is going, Jeff. Okay. Now, what is always going to be, since this has got to be a 1 for this to work, what is always going to be here is whatever number this is. Like if this would have been 2x to the 4th, wouldn't I have put a 2x cubed there? Okay. So that's why this kind of makes sense. The answer coefficients are going to be here. So I just bring him down. Whatever the hell he is, I bring him down. All right, so to truncate this a little bit, watch, this is where things get interesting. The next thing I did was 1 times 3 to get 3 here, and then I change the sign, right? So here's where that's caught. -3 times 1 is -3. I don't have to change the sign because I already did to begin with. 2 minus 3 is, see where we are?
Oh.
That's where we are. 2 minus 3 is? -1. -3 times -1 is? -3 times -1 is? 3. So see, bring this down, it gets me started. This times this there, add. This times this there, add. 6 plus 3 is 9. See where we are?
Yes.
At the only part that's important in this whole thing.
Okay.
9. -3 times 9. Add. Multiply. Add. Now, here's the key. What was the power? What was the highest power in the original problem? And I'm dividing by x, basically, right? So that's going to be the coefficient of x cubed. They all drop by a power. So what's the answer? X cubed minus x squared plus 9x minus 25 plus 93 over the thing I divided by. This part's always the remainder term. Oh shit. That's right. That's synthetic division. That's the same thing matrices do for systems of equations, and you're all going to hate matrices at first, if you've never seen them before. But then you're going to realize, oh, it's doing the same thing this is. It's trying to just focus on what's important. So look at that, look. Huh? Hey. Some of these problems you'd have to turn your paper this way just to fit all the shit in there.
Yeah.
Synthetic, no, it's nice. Yes?
How come they never showed us this method before this class?
I don't know. They could have. So we'll do some more synthetic. I'll bring that worksheet tomorrow. I've got the steps all explained. I just didn't print it out. All right.
Should have just taught us that instead of that.
Why is this important?
It's gonna help.
Because if this was x squared plus 3, I couldn't do synthetic at all. So this is still important. So synthetic is so easy because it's got so many restrictions. The bottom's got to be linear. The first number's got to be 1. Right? But if you have that situation, it's easy.
Right?
Say again?
They all have, the top has to be in order, right?
Yes,
You can't
exactly.
be
So it's got that restriction too.
You can't be
So it's got to be in order. If I didn't have an x squared term, I'd have to put a 0 in that place, and you can forget that real easy.
Okay.
Every place has got to be represented.
But you could still do the synthetic way if you just put a 0 in there
Totally.
instead? Oh,
I love it. And why does that make sense? Because one thing that this has not got that we have in our normal number system is 0. It shows up, right? 0 means I have no hundreds. But if I just wrote x cubed plus 6x minus 7, you have to realize there's 0 x squared. I'm not going to write 0 x squared. Why the shit would I write that? But you have to realize it's 0. So when you set that up, you'd have to be 1, 0, 6, negative 7.
Yeah.
0 x squares.
How does that throw your answer off? Like how
If you forgot the 0? Or how do you mean?
When you write it out, how would you write out your answer?
All right, let's do this real quick. Let's try this out. So say my problem was this. Let's say that's my problem. What am I going to put in the penalty box?
Positive 2.
Positive 2. And then I'm going to put what?
1.
1?
6.
0.
0.
6.
Negative.
It doesn't throw anything off at all. It's just a 0 sitting there. 1 comes down, 1 times 2 is 2. Add, multiply, add, multiply, add. I mean,
Well, your variable, like the x to the third, x to the second, what?
oh, what was the highest power here?
3.
So this is going to be coefficient of squared. So my answer is x squared plus 2x plus
Okay.
10 plus 17 over x minus 2.
Okay.
What's up?
No, I was saying it's 13.
Uh-huh.
I don't want to. It's 13.
Is it 13?
Yeah.
Oh, 13, yeah, thank you. I was speeding up there at the end. Oh, don't, please, you, yeah. It's fine. I don't care. I'm going to make mistakes. 'Cause I'm not going to be one of those teachers that like, oh, I'm not going to make mistakes. Shit, man, I'm human, I make mistakes. Even if Steph Curry misses a 3-pointer. Not too many, though. Okay, is that decent? So we'll do some more synthetic tomorrow. Because it is really powerful, and I like that you guys realize. Yeah, please. All right. What else from the review stuff?
Page 255.
Oh,
The delineation.
all right. We're going to do that today. We haven't even talked about that yet. The function stuff?
Yeah.
Yeah. Yeah.
28. I was confused how they got.
Oh, okay. All right. Somebody got this stuff here. Just to remind you guys, if I'm ever going too fast over something, you have got to ask questions. You got to slow me down. If nobody's asking me anything, I'm just going to kind of naturally keep going. You understand? Please don't. If you ask me, I'm not going to go, okay. This is my job. And like I said earlier, I live off questions. I hate classes. My other class is kind of quiet so far. I hope they speak up. Yeah, if you watch this, yeah. But you guys, I feel like you guys are asking questions. I love that. It's quiet. I'm like, I'm going to go a little insane. Yes?
So will there always be times that are waiting for us to ask questions at the beginning of class?
Yeah.
Okay.
Yeah. I totally forgot what the other, 28. Is that it? Yeah. I have a special place in my heart for the people that divide by 11 and say you're done. Of course you're not done. You can't say that you solve for x when there's x's on both sides. It doesn't make any sense. What part of this problem tells me I can't just get my x's on one side and divide and be done? There's a
Exponent?
exponent. There's an exponent other than 1. There's an x squared term, right? Some exponent that's different from 1. So my x terms are not like terms. I can't get them together. So what method do I have to use then? What do I have to make happen?
Subtract the 11x.
Yeah, why? I want to make this sucker equal to 0, because then I can factor and use that whole idea of two things multiplied by 0. There's only one thing that can happen. One of them's got to be 0. So if I subtract 11x and put it in the right place, and this is one of the hopefully relatively easier forms of factoring, right? Because I know what the beginning is, x and x to make x squared, but what factors of 10 add to be negative 11? Beautiful. Whenever this is 1 off from this, if it works, it's going to be this and 1. That's the factor that sometimes we forget all about. Or like 2 and 5 and this shit, it doesn't work. 10 and 1. So minus 10 minus 1. Is that cool?
So can you explain the reasoning again how you do to subtract the 11x?
So if that was not there, I would divide by 11, x would be 10 or 11. That'd be done. If that was an x, what would you do first? Subtract x, because then I can get my x's together because they're like terms. Are my x terms like terms in this problem? No. So I need a different way to solve it then. The way of getting all your x's on one side, all your numbers on the other side, only works when all your x's are like terms. Right? So if they're not like terms, I need another way to do it. The most likely candidate is get it equal to 0 in factor. Or get it equal to 0 quadratic formula if it doesn't factor. Right? What are my two answers then?
10 and 1.
Cool. And you can check it. 10 squared plus 10 is 11 times 10, 110. 1 squared plus 10 is 11 times 1. 1 plus 10 is 11. Cool, I like it. Yes?
So why is x equal to 10 and 1 and not negative 10 and negative 1?
Oh, all right.
Is that just
Because
minus?
negative 10 doesn't make the 0.
Oh, right.
So the step I'm skipping here is you say either this number is 0 or this number is 0. Which means either x is 10
Oh, okay.
or x is 1.
Got it.
So the quick way is just opposite sign those.
Okay.
Be really careful. If I had this, then you might want to write out the equation, right? You can't just say 5 and negative 7 because you got 2 and 3. So it would be 2x minus 5 equals 0. Solve it. 3x plus 7 equals 0. Solve it.
Okay.
But it's just a dinky little x minus 10, and you know it's 10. That's what makes it 0. I like it.
When I was doing that problem, I did the extra step of the factoring method of where you kind of like group them.
Oh, yeah.
And if you like put them in the wrong places, it kind of messes up the whole problem. So
Where'd you put stuff?
after you figure out that it's negative 11x plus like 10 to get the thing, you put those in the middle, right?
Put what in the middle?
So it
Oh,
would be like x squared minus 11x plus 10 or something, right?
well, I mean, that's what that is. But now you got to
Yeah.
break that middle term up if you're doing it that way. So factors at 10 that add to be negative 11.
Oh, okay, let me do that.
And see, that's why I want you to realize, if there's a 1 out front, this way will work. But why? Because the numbers you get are the numbers that go into the answer. So, you see, I'm not saying it's wrong. See, so what factors of 10 add to be negative 11? Negative 10 and negative 1. So you can put negative 10x
Yeah.
minus 1x plus 10, group it. But why when those are the answer, right? You'll get there eventually if you do this work, but if there's a 1 out front, the numbers you get are the answer. If the first number was not a 1 or something, then the grouping will help you put everything in the right place. It's a little more than just getting those numbers. There's more involved. We'll talk more about that form in a bit.
But how would you get, if you did factor the x squared minus 10x and then the negative x, like how would that end up with 10 and 1?
Like that.
Because they have common.
You gotta take an x out, x minus 10. You gotta take a negative 1 out to make that x minus 10. And then they both have x minus 10, and then x minus 1 is left.
Okay.
Yeah. This is a real easy one to make a negative mistake on.
34.
Oh, yeah. All right. No. Okay. So real quick, if I had this, real quick, let me do one thing before I do your problem. How would I solve this for m? Bless you. I don't know what that was. How do I solve that for m? Everybody makes a huge deal out of this. They're like, there's no numbers. Who gives a shit? But the steps you do doesn't care. And don't tell me there's no numbers. Yeah, there are. Y is a number I don't know yet. M is a number I don't know yet. They're all numbers. So if I had this instead, 5 equals 10m minus 15, what would you do first? At 15. So what I'm going to do first here, get rid of that. Same way you would get rid of that. Wherever your m is, your variable is, you get rid of the other shit. So there's my m. I want to get rid of this shit. How do I get rid of this? Subtract b. Y minus b equals mx. Well, how do you get rid of x? Divide by x. Right? So m is that. Okay, so I want to start there. When there's one letter you're solving for, that's how you do it. What's wrong with this one is
They're like.
there are two freaking C's.
Yeah, but with different letters.
This is number
34.
34. All right. You ready for wondering about what's in this bottle? There are not two C's up there. There aren't. There aren't two C's. There's one C that was distributed. So let me undistribute it. Take a C out, what's left?
B plus D.
And how do you get C by itself?
Okay. Yeah.
Divide by E
Yeah.
plus D. I love it. Once you see that, you're like, oh shit.
Oh,
Okay.
yeah, I didn't even.
Whenever there's two of the letter you're trying to solve for, get them all on one side that's already done for me, and then factor it out.
Yeah.
And then you divide by the shit you don't want.
All
So the
right.
next step would be divide by B plus D. To be honest, that's how we, if I had 10 equals 7x plus 3x. Watch me go a little crazy for a second. 10 equals x times 7 plus 3. Huh? Why don't we do that step? Because I know what 7 plus 3 is. Why would I do that step? Here, I don't know what the hell b plus d is. Purple? I don't know what the hell b plus d is, right? That's why I got to do it this way. It still is this way we do it, but why do we skip that step? Because 7 plus 3 is freaking 10. But see, that's the same thing. And then I divide by 7 plus 3. But 7 plus 3 is 10, so I get 1. So here, I have to write b plus d because I have no idea what they are. Aren't these like terms, though, in terms of c?
Yes.
So how many c's do I got? B plus d of them? Maybe. I love some of your faces, real high. Please let some of this make sense.
So you just come to the conclusion that you have to distribute the C out?
Yeah, undistribute the C. Let's do another one like that. Oh, what's up? Oh, stretch. So what if I had x w equals, I'll give you one letter, 5d minus, what do you got, Jeff? W f. Solve for w. Like that initial reaction, you just push that reaction away and go, I got this. What are you talking about? Where's my w's? Where's my w's at? Solve with me now. Yeah, so I want to get all my stuff that has the letter that I'm solving for together. As always. If we solve for x, don't I get all the x's on one side?
Yeah.
I'm solving for w. Let me get all the w's on one side. Yeah, there. So then I get xw plus wf equals 5d. And then undistribute the w. Factor that sucker out. Do you guys see? That's the steps. W times. And then divide by x plus f. Boop. W equals 5d over x. Now, part of your brain goes, I didn't expect that. That doesn't look like way. You can't expect anything from this. This is a little bit, a little more complex. So don't freak out and go, that can't be right. It doesn't look right. You don't know what it's supposed to look like. Right? That's part of it is I think some of you guys just second guess yourself and go, that can't be right. Let me go do something else. That's right. How do you check this? You plug numbers in for shit. Right? Plug numbers in for X and D and F, everything that's not W, and then just make sure that this comes out to what you get there. I mean, that is one way to do it. You don't have to do that. If you want to, you can try. All right. Is there anything that we haven't talked about yet in that assignment? Any other questions? Okay, so let's do this. Let me give you this. I printed this out in a strange fashion, but you're just going to have to deal with me. All right. On one side of this, it talks about the factoring where the first number is not a 1. The other side's got function stuff on it. We're going to get in that in a little bit, so just focus on the side with the factoring stuff. I'll bring a fan or something. This room's always hot. So on the factoring side, I want you to do those first three problems real quick. ABC at the top there. The part factoring side, right? Not the function side. Not this side. This side. The factoring side. Yeah. I'm still going to have somebody doing the function side. Roll up. Oh yeah, I two things. I sent out an email reminder about the survey. Several of you already done the survey. It's fantastic. If you haven't, just go do that when you get that email. Also, don't forget on the website there's a factoring handout thing that I didn't print out. You can print it out for yourself if you want to. It goes over all the methods and how they work. If you want that for yourself.